Welcome. On this video, I'm going to be doing a lesson about reviewing, factoring with a GCF, and also when a equals 1. Alright, so on the first problem, it says factor the common factor out of each expression. So we're already given a hint due to the instructions. On this problem, when you consider all three terms, the greatest common factor is 7. So I'm going to write that down, and I'm going to divide that out of each of the terms. There was no variable as part of my GCF, by the way, because this is into the 0 power. Alright, I'm going to divide that on all of them. 14n squared divided by 7 is 2n squared. Negative 63n divided by 7 is negative 9n. And negative 7 divided by 7 is negative 1. And there, I'm actually completely done. The instruction said to factor out the common factor. It didn't want me to factor anything further, and actually on this one it wouldn't factor out further even if we tried. So remember that some problems are as easy as this. Looking on to numbers 2 through 9 on this lesson, and that will be it. We're going to factor each of these completely. So on problem like number 2, you don't need to do factoring by grouping because the value of a is 1. All right. So when the value of a is 1, you don't need to do factoring by grouping. You simply take the value of c, which in this case is negative 40, and you figure out what pairs of numbers multiply to negative 40. I'm going to write those out really quick. And negative 5 times 8. And also the negative could have been on the bigger value. So 1 times negative 40 and so forth. And 5 times negative 8. Alright, now that I've written out all those pairs of numbers, I'm looking for the pair that adds to the value of b, which is negative 6. As I look through here, 4 times negative 10 is negative 40, but when I add them, 4 plus negative 10 would in fact be negative 6. So I'm ready for my factors of x plus 4 times x minus 10. Again, the x minus 10 could have been written first. Alright, so that's a nice reminder of how to factor whenever the a value is 1, and that's all we're going to be looking for today. We are not going to have any problems on this lesson where the a value is not 1 after you factor out any GCFs. Okay, on number 3, while this might read as you would need to use 0, well, that doesn't make sense. There's just a greatest common factor here again. So even though they didn't say use greatest common factor, you're always keeping your eye out for a greatest common factor. Here the greatest common factor is n because it can be divided out of both terms. So n, and now I'm going to divide, n squared divided by n is n, negative 5n divided by n is negative 5. The n's canceled. Alright, so this is actually finished whenever this is your situation. Usually if it's a binomial like that, it's going to be something similar to what I just did. So in a problem like number 4 here, you're going to have a greatest common factor first that you would want to identify. The greatest common factor here on this problem is 5. So I'm going to factor that out first. I'm going to have 5 times x squared. I'm just dividing it here. 10x divided by 5 is 2x. Negative 75 divided by 5 is negative 15. All right, now I try to factor it a little further if possible. I'm going to take that value of c, which is now negative 15, and write down numbers that multiply to negative 15. This is just an exercise in your ability to multiply, so hopefully you're not struggling with this. Alright, of those pairs of numbers that multiply to negative 15, negative 3 times 5 is the pair that would add to positive 2. So now I'm going to use that. I still have my GCF of 5 times. I would now have x minus 3 times x plus 5. And there's my final answer. There are 3 factors on this problem actually. Okay, I'm going to skip over what I had as problem number 5, go to problem number 6 here. Yet again, it does have a GCF here. So if you see a leading coefficient, something other than 1, really want to try to find a greatest common factor, if at all possible, which there is one here. So my greatest common factor is yet again 5. So I'm going to factor that first. So 5 will be multiplying p squared, and when I do negative 60p divided by 5, I'm going to have negative 12p. and then 100 divided by 5 is 20. All right, now I'm going to use the 20 and find pairs of numbers that add to negative 12. So 20, I could have 1 times 20, 2 times 10. Well, I see that 2 times 10 adds to positive 12. So to make it add to negative 12, I'm going to make it negative 2 times negative 10. All of a sudden, that's the pair I was looking for. So you don't have to write all pairs, like I ignored 4 times 5, for instance, because once you find your pair, you don't need to write the rest of them down. All right, moving right ahead, I'm going to go ahead and write down my 5 times. I'm going to now have p minus 2 and then p minus 10 as my factors. If there's not a pair of numbers that multiplies out like this, then you would have stopped on your previous step, but because there was a pair of numbers that worked out for me, I went that extra step. All right, looking at number 7, there is no greatest common factor here, so I'm simply going to go ahead and start working with the 28 real quick. So I'm going to write down things that multiply to 28, as you've kind of probably caught on by now. And 3 does not divide into 28, but 4 does. 4 multiplies with 7, which happens to be the pair I was interested in. I don't need to continue, like I know negative 1 times negative 28 would multiply, but since I found the pair that adds to b, I don't need to keep going. I'm just going to stop right there. So I'm now going to have x plus 4 times x plus 7. And I'm done there. Okay, the last one, I'm going to skip over number 8, and the last one I'm going to be doing is number 9 with you. All right, so on this one, again, you see something other than 1 as your leading coefficient, you're going to try to factor that out if at all possible, and sure enough, there is a greatest common factor of 4. 4 will divide into all of these terms, so I'm going to use that. So I'm going to factor that out first, so it's going to be 4. X squared divided by 4 would be 1x squared. 16x divided by 4 would be 4x. And negative 20 divided by 4 would be negative 5. Now I'm going to see if there's anything that multiplies to negative 5 that adds to 4. And 5 is a prime number, so this ends up being pretty easy. It's either negative 1 times 5 or 1 times negative 5. And sure enough, it's the first pair that I wrote down that will add to positive 4. So here we go. 4 times x minus 1 times x plus 5. Okay, so that covers the lesson. There is one last thing I wanted to talk about, and I'll show you that right now. So here's one of the things I wanted to show in addition to the problems I had already set, was whenever you're trying to factor something like this, there is no greatest common factor. So I'm going to go ahead and work with the 3 really quick. So I've either got 1 times 3 or negative 1 times negative 3. Unfortunately, neither of these actually add to 2, so I can't factor this. So I'm either going to say one of two things as my answer. You're going to see not factorable a whole lot as an answer, or another way to present this is that this expression is what's called prime. Just like prime numbers cannot be divided by anything other than 1 or themselves, same thing about this expression. It could be divided by 1 or itself, but nothing else. Be expecting one of those two answers when that happens. All right, and here's the very last problem I wanted to show really quick, telling me to factor this expression. So I am going to start with the GCF again, and the GCF here is 2. So I'm going to factor that out. 2x squared divided by 2 is 1x squared. 2x divided by 2 is 1x. And 10 divided by 2 is 5. Now, like the other problems, I'm going to try to factor this further, and I'm going to write down the number 5 over here. And I'm looking for a pair of numbers that multiply to 5 and add to 1. I'm going to go ahead and write down the numbers that multiply to 5 really quick. You got 1 times 5 and negative 1 times negative 5. Of those, nothing adds to the 1. So this adds to 6, this adds to negative 6. So I can't factor it any further. Now this is not prime because I was able to factor it with the greatest common factor. So it was factorable, just this is my end point. This is the end result, even though it couldn't factor further. This is considered factored completely, so just be mindful of when to use what answer. All right, please email me any questions that y'all got. Thank you very much.